architecture from NIST. Okay, so NIST is actually a government organization of US, and the full form for NIST is I think National Institute of Standards and Technology, right? Which has actually given certain guidelines and certain frameworks related to the big data architecture. And plus, we will be also going to look into the Hadoop side. Okay. Why big data architecture, right? So, as we all understand about big data, right? So we are talking about the huge quantity of data. We are not talking about the data in actually gigabytes. So we are not talking about the data in something like the 10 TB or 20 TB. But rather, we are talking about very, very huge data, which is there in something like 500 TB or in petabytes or in exabytes. Right? So let's look into the reference architecture, right? So that a particular project manager or a particular data architect or a technical architect is really interested in, and what are some of the best practices around it, right? So what are some of the benefits of a big data reference architecture, right? So consider this particular document as a kind of a reference document, right? Wherein they are talking about some of the best practices, right? So just like it actually provides the common language for the various stakeholders, be it your the senior management, be it your data architects, or be it your developers within the particular team. And it encourages the adherence to the some of the common standards, right? And when I'm talking about the common standards, I am talking about the where exactly to store your data, how you should actually process your data, how you should actually analyze your data, right? And certain patterns around it, right? And plus, it also talks about some of the big data components and the processes and the systems in totality, right? And it is something vendor agnostic. Okay, by vendor agnostic, I actually mean to say that once you have actually referred to this particular architecture document, then you can actually create your big data solution either on Google Cloud, either on Microsoft Azure, or either on premise, right? And it actually ensures all these particular things related to portability, usability, and interoperability, and these particular stuff. So this is actually a kind of a NIST big data reference architecture, right? So more details of it, you can actually see it from this particular URL, which is bigdataframework.org. And let's talk about this particular site, right? On the y-axis, we have the information technology value chain, wherein we are talking about the hardware, wherein we are talking about the compute, wherein we are talking about the storage and all. And this is something with respect to the information value, right? So what is the value you are getting? The first thing is the big data framework provider, okay? And what that particular provider is actually giving to you, what level of infrastructure this particular provider is giving to you, and what are the configurations for those particular virtual machines, what is something with respect to the storage, what is something with respect to the network, right? All those particular things, right, is being governed by this particular big data framework provider. On the top of it, you have your big data application provider. Once your infrastructure is being set, then you can actually create your application. And when I'm talking about the application, I'm talking about the data pipeline over here, right? Just like when I'm talking about the collection step, I'm talking about that how you will be going to ingest your data, how you will be going to prepare or process your data, how you will be going to save your data, and how you can actually do the analytics and the visualization on the top of that. And you can also control the access privileges for different users and different applications who will be going to access it, right? On the left hand side, we can actually see the data provider, right? So what are some of your sources from where you will be going to gather this particular data? And on the right hand side, we have something like data consumer, that who all, okay, and what all applications will be going to access to this particular data. And once this particular big data application provider has been actually set up, or your data pipeline has been set up, So then you can actually orchestrate this particular pipeline. By orchestrating a particular pipeline, I mean to say that whether you are running this particular pipeline once a month, or whether you are running this particular pipeline on a weekly basis or on a daily basis, or you are actually running this particular pipeline for your real-time use cases, right? And all these particular things are being governed from the security and the privacy perspective, right? How much secure this particular end-to-end architecture is, right? And how you will be going to manage this particular architecture, right? Any So let's look into the distributed data storage and processing, right? So last day we actually looked into a particular term in the wave number 2 about the distributed storage and distributed processing, wherein the data is actually being stored in different nodes or in different virtual machines within the Hadoop cluster. And also when I'm talking about the data processing, that is also happening in a kind of a parallel fashion across those particular virtual machines. It is not a particular single virtual machine wherein my entire data is being saved or wherein my entire data processing is being done. However, in reality, we are talking about the distributed thing, right? So this is something that is related to the wave number 1 we actually looked into, right? Wherein that this is something also being referred as the traditional data analysis, right? Wherein there are different systems, just like your CRM system, ERP system, and finance system. With the help of the UTL tool, you are actually bringing in this particular data into your data warehouse. Once the data is there in the data warehouse, then you can actually do the BI reporting and all those particular stuff. Right? So what so what is uh, what are some of the disadvantages of this particular architecture? We looked into that particular thing last year.
So is it real-time, is there like the initial real-time processing?
Right. So that is something named as velocity, right? We talked about that, right? Yeah. What else?
Variety and volume.
Yeah, variety and volume. Very good, right? So we learned about 3 V's last year, which is your volume, velocity, and variety, right? In this particular traditional data analysis, right, when I'm talking about the volume perspective, since this particular data warehouse is being installed on a single virtual machine, right, so we really cannot actually hold something like the petabytes of data. We cannot actually hold something like exabytes of data, right? This particular traditional data analysis cannot support the use cases related to real time, right? And plus, we cannot also analyze the unstructured data. So, what do I mean by unstructured data? So, can you just give me a few examples?
Unstructured.
JSON
No, the JSON files is something semi-structured.
and for files.
Huh?
Images.
Yeah, images. What else?
Audio files, video files.
Audio files, video files, free-form text, right? PDF files, right? So there is something like 97% plus of the data within the world is actually unstructured in nature right now. So this is something about the big data environment, wherein we are talking about now the wave number 2, right? Wherein we are talking about the distributed storage and distributed processing, right? And we are making the use of the commodity hardware nodes, right? In enable scale out, right? What do we mean by scale out? what do we need?
Expansion?
Huh?
Expansion?
Extension. So can you please elaborate it more?
Like waiting for bigger data.
For bigger data, right? So how we can handle bigger data? How we can actually extend?
To wait to settle.
Huh? Demographic?
You move to third wave mode?
No, no. We are still there on the wave number 2.
Okay.
So, so there was one thing we actually learned last day, right? Uh, so the first term is scaling up and down, and the second term is scaling in and out. Okay, let us try to understand the difference between both of them. When I'm talking about scaling up and down, right, I mean to say that suppose we have a machine, okay, or we have a particular server, and the configuration of this particular server is 4 virtual core CPU plus 16 GB RAM plus 1 TB of this. So by scaling up, we mean to say that we are still having the same virtual machine only, but rather than 4 virtual core CPU, I am actually making it something like 16 virtual core CPU. Instead of 16 GB RAM, I am actually making it to 64 GB RAM. And instead of 1 TB of this, I am making it 10 TB of this. Okay? So this is something you are scaling up or scaling down, right? Wherein, when I'm talking about scaling down, rather than having 4 virtual core CPU, I am making it 2 virtual core CPU, right? I am scaling the machine down, right? I'm scaling it down. The only criteria over here is that I am playing with only one machine. Okay, I am playing with only one virtual machine over here, or only one node. However, when I'm talking about scaling in and scaling out, last day we learned about that we have to create a particular cluster, and in this particular cluster, suppose you have 3 nodes. Okay, you have 3 nodes, and these particular nodes are actually connected to each other, right? Wherein your data is being saved, wherein your processing is happening in a distributed fashion. So now, when I'm talking about scaling in, I am increasing these particular number of nodes from 3 to might be 5, right? Wherein I am bringing in 2 more nodes, right? And I am actually associating this within this particular cluster. Okay? This is actually an example related to scaling out. Okay, and by scaling in, I mean to say that from 5 nodes we are bringing to 3 nodes or might be to 1 node. Clear? Clear to everyone?
Yep.
Is there any question?
Yeah, so yeah, when you do scaling up or down, is it just you get better devices with better CPUs and
No, no. So we are actually talking about the same level of machines. Okay, so just like suppose you have created a particular cluster of something like this, right? With this particular configuration. So you are actually scaling it out with the similar configuration of machines. Okay. However, definitely you can also do the upgrade of these particular machines also. Okay, so that is also possible. But in normal scenarios, when we are talking about scaling in and scaling out, we are talking about the same level of configuration of these particular machines.
so when you say level, do you mean like so you're not upgrading as in like upgrading the device, but how are they on the same level if they're getting more RAM or just space? Or, is it just because they're virtual? No, they're not virtual.
No, so what we are doing, right? So last day we took an example for American Express, right? Wherein American Express was actually having a particular cluster of something like 800 plus nodes, right?
Mm-hmm.
Right? So we can actually increase these particular 800 nodes to might be 1200 or might be 400, depending on the workload, right? But 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 we really cannot do something like this wherein I am creating a particular cluster. I do have a particular machine wherein this particular machine is only 4 virtual core CPU, and there is another machine which is 16 virtual core CPU, right? So that is not something possible. I need to be consistent with respect to the configuration of my machines within the cluster. I can either do the upgrade of all the machines, or I can either do the downgrade of these particular machines, but definitely the configuration for all of these particular machines needs to be same within
Okay,
my
so
cluster.
they're all like the same type,
Yeah,
but the number of them is increased.
right, right, right.
And then when it's scaling out, is it just
So
is it
that is actually scaling out. Okay, that is actually scaling
oh,
out wherein we are actually increasing the number of machines. Okay, so this is something out and this is something in. Okay,
so,
scaling in and scaling out.
so when it's scaling up, it's everything is getting upgraded.
When I am scaling out, I am increasing the number of virtual machines from 3 to 5
Sorry, can I
of
just?
the same. Yeah.
She asked about scaling up and down there as well.
Okay. So when I'm talking about scaling up and scaling down, this is something about the upgrade of a particular machine, right? From 4 virtual core CPU to 16 virtual core CPU, or vice versa.
Okay. So the left side is scaling up is upgrading, and scaling out is just adding number of devices.
Right.
Okay.
Okay. Right. So because of this particular reason only, right? Because of this particular reason only, we are actually having different nodes, right? And we are following the practice of the storage, distributed storage, and distributed computing. Right? Okay, so we are not relying on a single machine. Okay, and the beauty about having a particular cluster is that suppose if in case anything happens to this particular node, okay, if in case anything happens to this particular node, then still I am having these particular leftover nodes which will be going to handle the required workload, right? And there is also a particular concept of a replication factor that we will be going to learn in a short while. Any questions?
Regarding to the distributed storage, how
Mhm.
does that actually work? Is it like maybe computer one would be storing A to B, computer two would be storing B to C, that kind of thing?
Yes, so very good question, right? So just park this particular question for 5-10 minutes, okay? And I am coming over there. Very good question. Okay? So so right now, what we are talking about that we are making the use of the hardware nodes to enable the scale out. Okay, we are making the use of the distributed storage. We are making the use of the distributed processing to enable the parallel processing, right? And we are making the use of the advanced analytics and the visualization technology in order to analyze and prepare those particular dashboards. Right? So this is something about the wave number two, right? Wherein now we are getting the data from different systems, be it be it the Twitter feeds, which are actually your real time data, right? And you are actually saving everything, and you are actually processing everything within this particular Hadoop itself. Okay, and once we have everything within this particular Hadoop cluster, then we can actually do the analytics and the visualization. Okay, so this is something about the big data storage, right? So let's talk about the storage side, right? So when I'm talking about the storage side, right, so there are some three different type of storage. Okay, The first one is your direct attached storage. The second one is your NAS, and the third one is your SAN. Okay. Let's learn about direct attached storage. Okay. Direct attached storage is something, a particular storage which is there within my computer or within my server. Just like I am making the use of a laptop right now, and I do have a disk of I think that a 1 TB of this, right? So it is actually an example related to direct attached storage, wherein the storage is directly attached to the computer. Okay. The second one is your NAS, okay, network attached storage, right? Wherein you are having a storage, right? And this particular storage is being attached to your network. Okay, so think about something like this, wherein wherein you have a storage over there, right? And now this particular storage is, and suppose you have a router over there, and this, and you are having multiple uh, machines, right? Which is actually accessing this particular storage, right? And all these particular things are there in a network, okay, in a single network. The problem with this particular thing is that suppose if in case anything happens to this particular storage, okay, or if in case there is a power failure, or if in case there is an issue with this particular router or this particular switch, then none of the clients or none of the computer will be able to access to this particular storage. Okay, and this is something for some small companies or for some medium enterprises, right? Wherein they really cannot actually go. This is something network. This is actually NAS, right? And this is something for small and medium enterprises, right? Wherein they really don't have the budgets to create the SAN. Okay, by SAN I actually mean to say storage area network. Right? So this particular storage area network is actually a costly affair, wherein you have multiple multiple storage devices, right? And these particular multiple storage devices are connected to multiple switch, okay, like this, okay, like this, wherein uh, your computers are actually getting connected to, okay, wherein your computers are getting connected to. Now, in this particular architecture, what we can see that suppose if in case anything happens over there, if in case anything happens over here, right? So in case of SAN, your data, okay, so suppose you have your data over here, this particular data is also being saved over here also, right? So you still have the copy of your data which is being stored in a different storage unit over here, right? Or if in case anything happens to this particular router or this particular switch, then still all these particular computers, okay, all these particular clients can actually access this particular switch, and from this particular switch they can actually access all these particular storage things, right? So we are creating a particular network over here, right? uh, Wherein the data is being replicated, right, and is being saved in different storage the storage types, right? And then there are different switches to which it is being connected to. Clear to everyone? What is the difference between uh, SAN and NAS network?
Does it mean that each part of each of the storage devices has got all of the data?
Maybe all of the data or maybe some of the data. Okay, so think about that. Suppose you have a particular drive A, right? And now you are actually saving this particular data over here also. Okay, A. It it does not mean that your data is also being saved over here, right? Or suppose you are having a B over here, right? Now this particular B is also over here, right? And this is something that is being used by some major enterprises or some top companies who can really afford the cost of this particular SAM, okay, of this particular SAM, right? And these particular storage things, right, are just handling your storage, right? However, with respect to the processing, right, so the processing is actually happening at these particular client machines only, right? So suppose I am talking about this particular client machine. This particular client machine will be just going to take up the data from this particular S1, right? And then it will be going to do the processing over here. These are just storage units, okay? Storage units, and are just storing the data. Clear?
Yes, yes.
Fine. So can you please unmute yourself, everyone?
Could you just briefly say that again, because it seems a bit the last one that you said about